In this session, I will discuss about the binomial probability distribution. Binomial distribution applies to cases where there are only two possible outcomes. Therefore, if you can see about the experiments with only having two possible outcomes, it will be one condition where we can apply the binomial distribution. Therefore, the binomial distribution is the distribution of counts. It is because we are using the counts while we are dealing with the binomial distributions, and it counts the number of successes in a certain number of trials. Therefore, in the previous video also I have told you about this thing. Therefore, in the binomial distribution, we are counting the number of successes among the certain number of trials. As an example, we can have tossing a coin and considering his heads as success and tails as failures. Therefore, in here you can see head and tail. Those are only two possible outcomes. Therefore, we may be able to apply the binomial distribution for experiment like this. Then the defective items in a lot of 200 items. Therefore, in here also among these 200 items, there may be good items, and then the next one will be defective items. There also you may have only two possible outcomes. Then the probability of each birth producing a female is zero point 0.5 and probability of each birth producing male is 0.5. In here also, if it is a baby birth, then it will have only two possible outcomes, whether it is a male birth or a female birth. And at the very beginning, I told you about one condition. It is just the two outcomes. Therefore, it is not the only condition that should be fulfilled if you need to apply the binomial distribution. Altogether, there are four conditions which should be satisfied if you need to apply the binomial distribution for a given experiment. Therefore, these are the four requirements which needs to be fulfilled. Therefore, number one is there should be fixed number of trials. Therefore, at the beginning of the experiment, we have to fix the number of trials. Then the second one is independent. This is that the trials should be independent. Therefore, trials must not depend on the previous one or the next one. Then third one should be two possible outcomes. I have stated it previously also. There should be two possible outcomes. Therefore, one will define as success and the other outcome will be then defined as the failure. Then last one will be same probability of success for each observation. Therefore, according to one trial to the next trial, the probability should not be changed. Therefore, same probability should be there for a success for each and every observation. And now we will see how to carry out a binomial experiment. Therefore, these are the steps that we need to follow if you need to carry out a binomial experiment. Number one, select how many times you want to toss the coin. Here I have taken the example as tossing a coin, and we will see how we can carry out this binomial experiment. First of all, you have to define how many times you need to toss this coin, and then you have to decide what should be the success. It means that once you are tossing the coin, you may get head or you may get tail when it is landed. Therefore, anyhow, at the beginning, according to your experiment, you must decide what side should be your success. It may be head or it may be tail. As an example, if you consider head as the success, then tail will be the failure. In the other way around also, you can consider their tail may be success, therefore heads may be the failures. Then third one is the make the coin fair. It means that probability of landing either heads or tail is zero point 0.5. If it is a balanced coin, then you will have the equal chance of getting heads or tails. Therefore, you must make the coin as a fair coin. It is because according to the trial number, the probability should not be varied. It means the successive probability should not be varied. And the last one is make the toss independent. It means that in here the second condition should be satisfied. Therefore, you have to make the tossers independent. It is because if the tossers are depending one on other, then you cannot apply the binomial experiment there. This is some exercise to identification of the binomial random variable. Therefore, if you toss a coin, then you can identify the binomial random variable, and here also it is the same concept as for the random variables. If it is denoted by x, then you can have number of heads obtained. Here I have considered heads as my successive event. Therefore, I am considering this binomial random variable is number of heads obtained. Second one, a one machine tool produce 1% of defective part. Here also I can have the random variable as number of defective parts. Third one, in a MCQ test contains two questions, each with four choices. And if you are guessing for a question, and then you can have the answers as correct answers or the wrong answers. Therefore, if you need to apply the binomial experiment, then you have to define the binomial random variable. Then this binomial random variable will be the number of questions answered correctly. And if you move for the last one, it is the next 20 births at a hospital. In here also you have to define what should be your successive event, whether it is a male birth or a female birth. Therefore, if we are considering female birth as a success, then we are saying the binomial random variable will be the number of female births. Therefore, if you are dealing with the binomial distribution, this is the equation or the formula that we are used to calculate the probability of a binomial distribution. Therefore, if you are going to calculate the probability value using the binomial distribution, you can use this formula. This formula says that probability of our random variable x, which equals to r number of successes. This is given by NCR with the standard notation into p to the power r into 1 minus p to the power n minus r. If you go through the definitions for this notation, then we can have n is the number of events, or we can say it as number of trials. Among this n, then you may have r number of successes. Therefore, r stands for the number of successes, and NCR is given by factorial n divided by factorial r times n minus r factorial. P is the probability of success of a single trial, and 1 minus p will be the probability of failure. Therefore, it is because addition of the probability of success and failure should be equal to 1. Therefore, these are some exercise you can follow throughout using this binomial distribution. In here, I will just go through the first one. Toss a coin for 6 times. What is the probability of getting exactly 4 heads? In a case like this, what we can do is, here you are tossing a coin for 6 times, and they are saying that the getting exactly 4 heads. Therefore, if heads is our successive event, then we can say we have all together n equals 6. It is because we have toss the coin for 6 times, and r is equal to 4. Among these 6 times, we got 4 hits. And then you have to identify what is the successive probability. Therefore, according to this case, they are saying, since it is not specifically said about this coin, we will consider it as a fair coin. Therefore, if it is a fair coin, we will have the equal chance of getting head and tail. Therefore, p is equal to 0.5. Therefore, now you have to apply this in the equation. Therefore, you will get probability of x where r equals 4, and this is given by NCR. Here it is 6 c times r into the p to the power r, 0.5 to the power r means 4, then 1 minus 0.5 to the power n minus r, it is 6 minus 4. Therefore, you can go through the calculation and you may able to get the value as 0.2344. Therefore, this is the probability of getting exactly 4 heads once you toss the coin for 6 times. Likewise, you can go through the second one also. Therefore, if you move furthermore, this is the binomial distribution table. Therefore, when we are discussing about the binomial distribution, I told you about you can use a formula to calculate the probability value. But using the formula is not the only way of calculating the probability values once you are using the binomial distribution. There is another way. It is called as the using of this binomial distribution table. But you can use this binomial distribution table only for given specific values of n x, means here r and the given probability values. But when you are using the formula for any given value for p, x and n, you can apply it. But when you are using the binomial distribution table, in the table, there may be only specific values for given successive probability. Therefore, you can take the probabilities only for the given successive probability value. Therefore, if you go through the same example, then in that, according to that example, what we had was n equals 6, r equals 4, or according to this table x equals 4, and the successive probability was p equals 0.5. If you go through this table, you can see that in the first column it gives the value of n, in the second column it gives the value of x, or according to here value of r, and these columns give you the values for the successive probability. Therefore, according to our example, we need to go for n equals 6. Here we can see it. And among these 6, where should be our r? R is now equal to 4. Therefore, you have to go along in this row. Therefore, if you go along this row until you are getting your probability of p. In here, you can see p equals 0.5. Therefore, if you come down and if you go along with this row, then you can see the given probability value is 0.234. It is the value that we have also obtained from the formula also. Therefore, if you need, you can use the binomial distribution, but you can use this binomial distribution only for a specific value for p only. But if you use the formula, you can use the formula for whatever value for n, x and p. And you can look about the skewness of the binomial distribution. Therefore, the skewness of the binomial distribution can be determined with the value of p. It means the successive probability. If the value of p equals 0.5, it means that the successive probability equals zero point 0.5, then we can say that the distribution is symmetric. If p is greater than zero point 0.5, distribution is negatively skewed. If p is less than zero point 0.5, we are saying that distribution is positively skewed. If you just sketch about these things, if p equals zero point 0.5, you will just get two sides equal, no any specific tail, but p is greater than zero point 0.5, it means the majority goes for the positive side. Therefore, you will get a tail for the left hand side. That is why we are saying it as negatively skewed. Then here P is less than 0.5 means majority of the observation comes for with the negative side or just the left side. Therefore, you may have a tail in the right hand side. Therefore, they are saying this as a positive skewness. This is a negative skewness, and here there is no any specific tail for the left side or the right side or the positive or the negative side. Therefore, we are saying this as a symmetric distribution. Therefore, if you are having P equals zero point 0.5, you are getting symmetric distribution, and P is greater than zero point 0.5, you are getting a negatively skewed distribution. If P is less than zero point 0.5, you are getting a positively skewed distribution. And now we will look about the properties of the binomial distribution. When we are going to discuss about the properties of the binomial distribution, you have to look about the mean and the variance of the given distribution. According to the notations that we have used, you can define mean mu equals n times p, where n is the number of trials and p is the successive probability. Therefore, using this equation, you can calculate the mean value for a given binomial distribution. And if you look about the variance of the binomial distribution, variance is denoted by sigma squared, and it can be obtained using the equation n times p into 1 minus p, where n is the number of trials, p is the successive probability. Therefore, 1 minus p will be the failure probability. Therefore, these are some exercise that you can follow up. Then we will look about the advantages and disadvantages of the binomial distribution. As the advantages of the binomial distribution, we can identify it is easy to understand. It is because it may be considered as the simplest distribution. Then easy to calculate by hand. Then for more effective results, n value should be small. Therefore, if you are having a small n values, it means if it is less than 30 or maybe 25 or 20 also, according to the situation. Therefore, in general, we are considering small value as if the value of n is less than 30. Therefore, if less than n is less than 30, then the results will be more effective. Then we will go for the disadvantages of the binomial distribution. Binomial distribution is complex to calculate if the value of n is greater than 30. It means that if you are having a large value for n, then it is complex to calculate. It is because we are considering the failure probability to the power n minus r. If the value of n is becoming large means, then you have to consider the power value or the value n is being a large value. Then another disadvantage of this binomial distribution is you can apply this binomial distribution only for the experiments which are having only two possible outcomes. Therefore, if you are having, if you got an experiment with having more than two possible outcomes, then you may not be able to apply this binomial distribution. Therefore, we can consider this as an disadvantage of the binomial distribution. And we are considering one disadvantage is if we are having large number of n, then it is complex to calculate the using the binomial distribution. Therefore, alternative method for this is you can use the normal distribution regardless of the value of phi. Therefore, as the number of replicates in the sample increase, it means the number of trials are increasing or it is becoming a large value. The binomial distribution tends to a normal distribution regardless of the value of p. It is the successive probability. Therefore, if you go through these graphs, you can see that in here you are having value of 0 to 5. Therefore, probability is 0.5, 0.7 to 0.001. Therefore, if you are having small values, then you will get a distribution like this. But If you are having the value of n increase, it means the number of successes are getting increasing, then this will tends to a normal distribution. Okay, this is actually all the things I need to discuss under the binomial distribution. Therefore, thank you all for joining with this session.